Welcome back to my channel Chemistry Drive with Nujmun Nissa. How are you students? Students, in my previous video I have told you about packing efficiency in solid state, in which we have studied the different packing efficiencies in solid structures like HCP, CCP and SCC. Now in my present video I have shared you the magnetic properties of solids, and in this we are going to study about different magnetic properties, and we are going to study these magnetic properties in reference to the solid structures. And as you all know that magnetism shows two types of things, that are attraction and repulsion, and repulsion is the sure test of magnetic properties. So with all these not taking so much time, I'm going to start my video. So let's start. Magnetic properties of solids. So on the basis of the magnetic properties, we are dividing solids into several groups. So these magnetic substances, they are diamagnetic substances, as you know. The category of these substances, they are solids and they are weakly repelled by the magnets. And the magnets with diamagnetism, they have all their electrons paired up. All the electrons are paired into diamagnetic substances, and the magnetic dipole moment is cancelled. Even then they have a small magnetic moment, and the examples of it are water, titanium oxide, sodium chloride and vanadium pentaoxide. So these are diamagnetic substances. Their electrons are paired up. They have a small magnetic moment. The next one is ferromagnetic substances. Ferromagnetic substances, they are strongly attracted by the magnetic field, and they behave as, they get permanently magnetized, so they behave as permanent magnets. The ions of ferromagnetic substances, they form small groups. Now they behave as domains. Upon application of magnetic field, when we apply the magnetic field, these domains, they are oriented in the same directions. Since these domains, they orient in the same directions, the magnetic behavior is strong. They show greater magnetism, and even after the removal of the magnetic fields, they behave as strong magnets. So such type of magnets, they are known as permanent magnets, and examples of it is iron, cobalt, nickel. The next one is paramagnetic substances. In these substances, the electrons are not paired up. They are weakly attracted by a magnetic field, whereas diamagnetic substances, they are weakly repelled, but paramagnetic substances, they are weakly attracted by the magnet. They are magnetized in the same direction as that of the magnetic field. This point to be noted. These are not permanent magnets, as we have studied in ferromagnetic substances. These are not permanent magnets. Paramagnetism, it is caused when one or more unpaired electrons, they are attracted by the magnetic field. Paramagnetism is present when there are one or more unpaired electrons. So they behave as temporary magnets, not permanent magnets. And examples of it is oxygen, copper ion, vanadium oxide, copper oxide and titanium oxides. These are some of the examples of paramagnetic substances. Our next one is antiferromagnetic substances. They have a net, as the name suggests, their magnetic moments is net zero, but they have the same domains as that ferromagnetic substances. These domains, they are oppositely oriented. That is why they cancel the magnetic moments of each other, and hence result in zero magnetic moment. The domains are cancelled out each other. The examples of it is manganese oxide and vanadium oxide. These substances, they are known as antiferromagnetic substances. The points you can understand here is that in ferromagnetic substances, the domains are aligned in same direction and they have strong magnetic behavior, but in this case their magnetic moment is zero. The next one is ferrimagnetic substances. They possess little magnetic moment, not more but little. The magnetic moment of the domains of these substances is aligned in parallel and anti-parallel direction. So we can see that the domains are aligned in both parallel as well as anti-parallel directions and in unequal numbers. They are present in unequal numbers. So the examples are magnites and ferrites. One thing is Curie temperature. What is Curie temperature? I have brought this slide in front of you because it is very important to study about Curie temperature. So it is the temperature at which any ferromagnetic material, it becomes paramagnetic. Any ferromagnetic substance, it tries to become paramagnetic substance. That temperature at which this change happens, it is known as Curie temperature. So at which a magnetic material completely loses its magnetic property. So it is a temperature at which any magnetic material completely loses its magnetic properties. So such type of a temperature is known as Curie temperature. So let's just have a look once again. Diagrammatically, ferromagnetic substance, all the domains, they are aligned in same directions. That is why they behave as strong magnets or permanent magnets. Anti-ferromagnetic, you can see that they are cancelling out their domains. The domains are in anti-parallel directions. Ferrimagnetic, they have a little bit of magnet moment, and in paramagnetic moments that there should be at least, they are not equally aligned. They are not paired up, but at least one or two unpaired electrons should be present. So that is paramagnetic. Whereas in the case of diamagnetic, they have paired electrons with opposite spins. So this is diamagnetic. So I hope that I have shown you this thing in diagrammatic form also. So it is quite clear to you the different magnetic properties of solids. So students, thank you for watching my video and keep watching it, and don't forget to comment in my comment section. Thank you.